Assalamualaikum and hi everyone. Today, KAMILIA and I, AFIFAH, will talk about the elementary particles.
Before we explain about the elementary particles, I am going to rule out four basic forces that interact with matters, which are gravitational force, electromagnetic force, strong nuclear force, and weak force. The first one, which is the gravitational force, is a force that binds between two objects with masses. It is the weakest of the four basic forces and always attracts masses together. Next is the electromagnetic force. It exists between two different charges and binds together electrons with a positively charged nucleus to form an atom. It also attracts different charges and repels the same charge. The third one is the strong nuclear force. This force only acts on quarks. It is a force that binds three quarks together to form a nucleon and also binds nucleons to form a nucleus. The last one, which is the weak force, it is a force that acts on both leptons and quarks. It can change the flavor of quarks to transform it into proton.
Now, I will explain about the classification of elementary particles. Elementary particles, not including photons, are now classified into two groups. They are leptons and hadrons. This classification is based on the type of fundamental forces that act on the particles. Leptons. A lepton is a particle which does not experience the strong force. It is acted on by the other three basic forces, especially the electromagnetic and the weak forces. As a particle, a lepton has very little mass, and so the gravitational force is ignored. As for the structure, it does not have any internal structure, meaning it is not subdivided into smaller particles. There are 6 leptons in the lepton family, and each has its own corresponding antilepton. Hadrons. A hadron is a particle which experiences the strong force, and it classifies as baryons and mesons. Protons and neutrons are baryons, while pions are mesons. Most hadrons have their own corresponding antihadrons. For example, we have antiprotons and antineutrons. A hadron has an internal structure, and scientists now believe that a hadron is composed of 2 or 3 particles known as quarks. A hadron may be one of the following, which a baryon composed of 3 quarks, which not necessarily all different, and a meson which composed of a quark and an antiquark.
Next is about quarks. Quarks are fundamental particles, meaning that it doesn't have an internal structure. This is similar to an electron, which does not have an internal structure too. Some quarks have masses smaller than a proton, while the other have masses larger than it. From the table, it is explained that a quark can have a charge of 1/3 or 2/3 of an electron. There are altogether 6 quarks that correspond to antiquark, which are up, down, string, charm, top, and also bottom. These quarks are acted on by a strong force. In other words, quarks are confined in the hadron. Once they try to move away, this strong force will pull them back. Quarks are a part of hadrons, while protons and neutrons are baryons. Quarks make up protons and neutrons, which in turn make up atoms of the nucleus. The difference between a proton and a neutron are in the flavor of each quark. A proton composed of quark UUD with a positive charge, while a neutron has quarks of UDD with no charge.
Kinetic energy has a continuous distribution, ranging from a very low value to the maximum value of Tmax, as shown in the figure. It means that not all beta minus particles carry the same amount of kinetic energy, some carrying less and some carrying more, although they originated from the same source. A physicist named Wolfgang Pauli in 1930 suggested that another particle was emitted at the same time together with the beta minus particle during a beta minus decay. The sum of the kinetic energy of the two particles would be Tmax. This explanation turned out to be correct because in 1956, this particle known as the neutrino was finally detected experimentally. The beta minus decay by carbon-14 can be represented by the nuclear equation below. Here are some of the properties of the neutrino. A neutrino is uncharged, so the electric force does not act on it. Since its mass is almost zero, gravitational force does not act on it. The strong force also does not act on it, as a neutrino is a lepton. It interacts through the weak force. The weak force has a range of 10 to the power of negative 17 meters. This means the neutrinos interact with nuclear particles only within distances of magnitude 10 to the power of negative 17 meters. Because of these properties, they do not generate visible tracks in the cloud chamber or the bubble chamber and cannot be deflected by electric and magnetic fields. Because of all these factors, scientists find that it is very difficult to detect neutrinos, even though a lot of them are available. Neutrinos are found in cosmic rays and in the core of a nuclear reactor. So that's all from us. Thank you for watching.